Welcome to session CMP391. This is the Amazon EC2 A1 instance, the all-new instance that we just announced. And I'm Sudhir Raman. I'm a product manager in Amazon EC2. And co-presenting with me today are Ali Saidi, principal engineer at AWS, as well as Shane Myers, principal production engineer at SmugMugö. So how many of you have heard about the A1 instance that we announced on Monday? Great. That's a vast majority of the audience. Another question. How many of you have built applications on the ARM architecture? Wow, great. Yeah, that's most of the audience as well. So we're really excited to talk about this new instance today. And as part of the agenda, we'll be covering, we'll take a closer look at the A1 instances. We'll talk about the key usages, the targeted workloads, the software ecosystem around both A1 as well as the ARM, and to help you get started on your applications. We'll also hear from Shane from SmugMugö. SmugMugö had access to some of these instances early on and have been able to run some of their workloads. So we'll hear from Shane on their experience and key takeaways. We also will round off the session with some demos. We will walk you through how to launch an EC2 A1 instance through the console. And we will also showcase a couple of container applications running on the A1 instance, courtesy demos that have been provided to us by our partners. So before we talk about the details around A1, here's a quick refresher around Amazon EC2 overall. So as most of you are familiar with, EC2 offers essentially virtual machines in the cloud through our instances. And there are 4 key parameters that most customers typically care about from our instance types, those being compute, network, memory, and storage. And these instances, based on the availability and the global infrastructure that AWS has, you can launch them in multiple regions and availability zones across the world. In terms of availability, we also support capabilities such as load balancing that allows you to route multiple requests through various instances. And we also support capabilities such as auto-scaling that allows you to essentially scale your instances following your demand curve and based on some of the parameters and conditions that you can specify. We also provide tools and capabilities for managing these instances. So when you're deploying instances, for example, through launch templates, where you can specify an instance type, the army that you want to use, and various instance parameters that helps you automate future launches. We have tools for monitoring these instances. For example, the CloudWatch tool, where you can monitor the resources as well as the various metrics of the instance that you're currently launching. And for administration, we have tools like Systems Manager that helps you securely manage your instances. Several different purchase options are available as well. So just a quick recap, we have on-demand, where you pay for what you use without any long-term commitments. Instances can be purchased as reserved instances with either 1 or 3-year commitments that gives you a significant discount over your on-demand. And we also have purchase plans Spot, which is extremely popular, which is basically unused EC2 instances that give you a significant discount over your on-demand pricing as well. So our customers run a variety of workloads in the cloud, and we have a number of instance types that cater to the variety of workloads that our customers run. So we have categories where we have general purpose instances that offer a balance of compute, memory, and network resources. We have burstable instances for workloads that experience occasional spikes in demand. There are compute-intensive instances that offer the best single-threaded compute performance. As well as we have instances that optimize for memory, where you're running in memory workloads or high-performance databases. Or your workloads could be storage optimized, where you need the highest IOPS or optimized for storage density. And in the last year, we have invested in multiple capabilities as we continue evolving these instances. So be it the choice of processors, we have brought in some of the fastest processors through our Z1D instances. We now scale our memory up to 12 terabytes for workloads such as SAP HANA. And we've also brought in capabilities for enhanced networking, such as the C5N instance that we just launched with 100 gigabits per second of networking throughput. And combine all of these capabilities, we also have options where customers can use capabilities such as Elastic Block Store, Elastic Graphics for more flexibility and performance of their workloads. And when these come together, we have a total of 175 different instance types that meet virtually every workload and every business need. And we are continually evolving our instances to optimize for further workloads so that we can deliver additional cost benefits. And part of that journey is also providing a choice of processors and multiple architectures within Amazon EC2. So today we have a number of instances that are powered by Intel CPUs, the Intel Xeon processor series. For example, within the last year, we've announced our C5 instances and our M5 general purpose instance that are powered by the Intel Xeon Platinum Skylake processors. We also, in the last couple of weeks, announced support for AMD and the AMD EPYC processor that gives customers more choice in terms of optimizations, both for cost as well as performance. And now, with our key announcement on Monday, with the introduction of the new AWS Graviton Processor, which is custom designed by AWS, featuring ARM cores, we now have support for ARM architecture in Amazon EC2 as well. So this essentially now delivers the broadest choice of processors and architectures within EC2 and the cloud so that customers can pick the right compute for the right application and their workload. So how did we get here to designing our own Amazon AWS Graviton processors and our CPUs? Let me call on Ali to tell us more about the details.
So, my name's Ali. I've been a principal engineer at Amazon for about 18 months now, and I was the technical lead for this project. And I'd like to start with some history. Back in 2013, we added the first cards to our servers to accelerate networking for our customers. And that created enhanced networking. And then the next year, we added another card. And this card came from a startup called Annapurna Labs. And we used that to move storage off of the processor onto these cards, provide EBS optimized by default. And that also improved performance for workloads that had storage in them. AWS really enjoyed working with Annapurna. And the following year, AWS acquired the company. And together, we started to create custom silicon for use in AWS servers. First one was for EBS. Then we also created a new device for networking, which is what ENA is. And these devices were used to create the first true Nitro cards that we talked about last year. How to take both storage and networking off the host processor onto these cards and give our customers better performance and larger instance sizes. As Sudhir mentioned, this week we've also had another card that we talked about that lets us offer 100 gigabit networking in our C5N instance, and also an HPC interconnect. And the team really has proven that they can innovate in silicon, they can move very quickly, and with that we asked them to take on a new challenge. With the proven success of building custom silicon for AWS, we asked the team to think about what an Amazon-built processor might look like. The first instantiation of this is the AWS Graviton Processor you heard about Monday. General purpose processors are great, and they're built to run a wide variety of workloads, but there are some trade-offs there. They include a broad set of capabilities that aren't always fully utilized in emerging workloads and aren't always utilized in the cloud. And those features add cost and complexity. With a custom processor, we can implement only what we really need to provide great value to our customers. The AWS instances are the first type powered by this processor. They use 64-bit ARM Neoverse cores and are the first processor that was designed by Amazon for use by our customers directly. And we're really excited about the possibilities here. We've been excited about the ARM ecosystem for a while. And part of that is because of what's unique to it. There are many participants in it, and that drives competition and innovation across every layer. So we're investing in capabilities in this area to be able to offer instances with unique performance and cost points, and be able to rapidly innovate and iterate based on the feedback we get from you on this first one. So coupled to that processor that we built, we've added the rest of the Nitro components that you heard about last year. So last year we talked about the Nitro system that powers our C5 instances. And these building blocks have let us release 66 new instances this year. That's compared to 23 in the previous year. So to build A1, we've taken those same modular building blocks that we're using on the latest generation of our instances and coupled them to the Graviton processor. The Nitro system is composed of 3 components: the Nitro hypervisor, Nitro cards, and the Nitro security chip. The hypervisor allocates memory and cores to instances, and since it runs on the host processor, we had to rebuild that for ARM. But it uses the same lightweight architecture as on x86 to deliver bare metal-like performance. The other components of the Nitro system are utilized with virtually no change. For example, the Nitro cards and the security chip. Just like in our C5, M5, and R5 instances, the A1 instances get EBS and ENA devices that are the same as what's offered in our existing instance types. And those cards, in addition with the Nitro security chip, provide system monitoring and security. So with those components, we were able to build A1. And I'll now pass it back to Sudhir to talk a little bit more about the A1 instance.
Thank you, Ali. So the Amazon EC2 A1 instance, it's now available in 4 regions. That includes US East, North Virginia, US East, Ohio, US West, Oregon, as well as EU Ireland regions. So let's take a closer look at the A1 instance, and we'll discuss some of the key benefits that the instance provides to our customers. EC2 A1 is the first instance that is being powered by the AWS Graviton Processor. And this instance is targeted for scale-out workloads, as well as ARM-based applications that are supported by the extensive ARM ecosystem. These instances are also expected to deliver up to 45% cost savings for general purpose workloads that can run ARM instructions. What are the key benefits that are provided by the instances? These are threefold. Firstly, the instances offer flexibility and choice for your workloads. So customers can now access instances that are based on the ARM architecture in the cloud and help and develop new applications and innovate based on the ARM architecture, while experiencing the flexibility, security, the reliability, and scalability of Amazon EC2. A lot of the familiar capabilities that you're used to, both from AWS as well as EC2, run seamlessly on A1 instances. For example, capabilities like EBS, capabilities such as networking, the armies, capabilities such as auto-scaling, all of these work seamlessly together on A1 instances. The second key benefit is lower cost. So as Ali mentioned, a lot of the targeted performance, power, and cost optimizations that we have been able to integrate into the Graviton processor enable the A1 instances to deliver up to 45% lower cost for general purpose workloads. And thirdly, built on the Nitro system, you can maximize the resource efficiency that is delivered back to the customer. So the Nitro system being a combination of the lightweight Nitro hypervisor and dedicated hardware essentially delivers all the compute and memory resources of the instance back to you so that you can utilize it to optimize your workloads. So in terms of the EC2 roadmap and portfolio, the A1 instances are positioned under the general purpose instance family. And this family today also includes the M5 and T3 instance families. So when should you use A1? For workloads that can be spread across multiple cores, and if your workloads can fit within the A1 memory footprint, supported by the ARM instructions and the ARM ecosystem, then the A1 instances are going to be a good fit for those workloads, and you can gain from the cost benefits. If your workloads experience variable CPU usage with occasional spikes in demand, then those workloads are going to be a better fit for the T3 instances, and you can gain the cost benefit from T3. If your workloads need more memory, or you need a balance of compute, memory, and network resources, or perhaps your workloads have dependencies on the x86 architecture instruction set, and then the M5 instances are available as well, which will be a great choice for those workloads. And outside of the general purpose family, if you're sensitive to the highest compute performance, or you need more memory, we also have other instance families in the portfolio. So here are some of the targeted applications for the EC2 A1 instance. So for applications that are scale out, such as if you're running web tier, containerized microservices, distributed data stores, or caching fleets, those applications are well suited for the A1 instances. In addition, application developers, enthusiasts, educators across the ARM developer community would also find these instances appealing because now you have access to the ARM architecture in the cloud in an elastic fashion. If you're wondering, would your applications need to change to be able to run on A1? So the answer to that is it's truly dependent on the specific application. Most applications that use open source software, say software such as Ruby or Python or Node, Java, these typically run well on multiple processor architectures due to the support of the broad support that we have from the Linux operating systems. So if you're running those kind of workloads, the A1 instances is something that you should consider. Applications that are using interpreted languages or are compiled at runtime should generally run with minimal to no changes. And some other applications may need to be recompiled. And if they don't rely on the x86 instruction set, you would expect them to compile with, again, minimal to no changes. I'm going to walk through some of the specifications and the sizes of the various A1 instances that we offer. So these instances are available in 5 sizes, starting from the medium instance, which is 1 vCPU and 2 gigs of memory. We have the large, the extra large, 2XL, going up all the way to the 4 extra large instance size with 16 vCPUs and 32 GB of memory. Each vCPU on an A1 instance is a single core of the AWS Graviton Processor, so running at 2.3 gigahertz. In addition to vCPUs and memory, all of these instances support enhanced networking, and they offer up to 10 gigabits per second of networking bandwidth for instances when launched within a placement group. The instances are also EBS optimized by default, and they support EBS optimized burst up to 3,500 megabits per second. So overall, these instances are integrated into the Amazon EC2 portfolio, and they essentially run just like any other EC2 instance, and you can launch them through the CLI or through the console. In terms of purchase options, we support all purchase options, be it on demand, 1-year reserved instances, 3-year reserved instances. The A1 is also available in the spot as a spot instance, and we also support dedicated hosts as well as dedicated instances. So with that, let me invite Shane Myers from SmugMugö to talk about their experience of running workloads on the A1 instance.
Thank you, Sudhir and Ali. So I am Shane Myers, Principal Production Engineer at SmugMugö. So to give you just a tiny bit background of who we are, SmugMugö is the safe, beautiful home for all of your photos. I like to describe it as our customers are families protecting their memories and sharing them with their families and friends, up to some of the top photographers in the world using our services to deliver images to clients, use us for print fulfillment and other things like that. A little bit more background is that we start in 2002 as a premium service and have been premium this entire time, no advertising. We are one of the first S3 customers, and we store petabytes of storage in S3. And we've been 100% EC2 for about 5.5 to 6 years now. It was quite a journey to get there, but once we were able to get entirely on EC2, it really enabled us to leverage the advantages of the cloud to scale our workload, change on the fly, and really literally pivot on a dime. In some cases, surprising some of my new coworkers, wow, you rolled that out in 4 hours. Went from concept to production in no time flat. We run hundreds of EC2 instances to support our workloads. And we also heavily use GPUs for a lot of image processing. And the other big bit of news for SmugMugö is earlier this year, we acquired Flickr. And so are now in the process of bringing all of the Flickr infrastructure onto Amazon as well, off of a traditional data center. But for the purposes of this, we're just focusing on ARM at the SmugMugö stuff because we've got enough balls in the air with Flickr. This is a simple architecture diagram of SmugMugö. So a request comes in from a customer to the internet, goes through CloudFront. We use dual origin setup in our CloudFront distribution. For just plain HTML, CSS, all that kind of stuff, it goes to a tier of web servers that are served via a load balancer and just traditional web servers behind it. But the second origin is our photoserve tier, and that is what it does, like it says. It actually serves the photos. Photoserve will talk to S3 to proxy through the actual image objects that have been pre-rendered, that are stored in S3. And anything that we don't already have a rendered size for, say we just happen to not render it, or somebody needs custom dimensions of a particular photo, we use a GPU cluster to do image resizing on the fly. And basically, it's literally lightning quick. And both those draw from S3 and apply our permissions models before serving to the end user, so there's actually no direct connection to S3. For the purposes of ARM, we focus mostly on the photoserve tier. It is a microservice, well self-contained, and kind of an easy first step to exploring the ARM ecosystem without upsetting too much in our infrastructure. To give you a little bit of our idea of our stack, we are a PHP FPM with Nginx shop. We use HA proxy. We run on Ubuntu 14, and we're heavy users of Puppet for configuration management of our EC2 instances. As part of this move, we are currently running on Ubuntu 14.04 Trusty, but the ARM versions of Ubuntu are only available 16.04 and 18.04. So we jumped straight to Bionic and started the process of migrating our operating system, which is non-trivial also because there was the upgrade from Upstart to System D in this process. So many different changing things under the hood. Puppet also had to change 3.4 to 5.4. And we had some bad habits with Puppet, like many people have been using things for a decade. And there's a lot of little hidden things that got enforced when we upgraded. So there was a lot of work that went into that too. Really, the bulk of the ARM work, though, was just compiling packages on ARM. We built our own PHP and ImageMagick and Nginx and HA proxy. So all that software needed to be rebuilt. Most things just rebuilt straight as it was. It was really nice. PHP, for instance, I just ran the build script and it was done in a matter of minutes. A few other things, HA proxy, I had to bump a few versions up to get a version that has more ARM support in the particulars of the code where that matters. And then we also have a few third-party packages, like profiling tools and et cetera, that come from third parties. And so we've had to locate ARM support versions of those, or in a few cases, just leave them out temporarily while those people catch up. Now that these instances are available to the general public, I imagine most companies are going to be compiling their ARM versions of packages relatively soon. So for us, some of our key takeaways were the cost savings. 40% is a significant cost savings. Now, with the size of our infrastructure, we've got a large bill, like many people do. So we are constantly paying attention to how we can save money and still deliver value to our customer. And so by switching to ARM with a 40% cost savings just from on-demand straight up is an easy win. We will continue also looking into things like Spot and driving even more wins to keep our bill down and keep things reasonable. As we are experimenting with these ARM instances, they look, feel, run just like any other EC2 instance. It was, in some respects, it kind of feels funny for me to be talking up here about this, in the sense that it was so easy to deploy to ARM. I mean, outside of sure I had to recompile a few things, but at the end of the day, 99% of my work was an operating system upgrade, not ARM-specific work. It was that easy. I just launched the box, start installing software. It works. It can take a production load almost instantly. It's EC2 as EC2 as that we know and love. Yeah, so once on Ubuntu, it's very little work for ARM. We are going to have to continue to work with a few of our third-party providers, like I was saying, profiling tools and other things, just to gain ARM support in those tools, since we just get binary packages from them. And like I said here, definite candidate for our photoserve tier. So our photoserve, like I was saying, is a microservice that, since it's pretty well self-contained, it's a great candidate to do this for. And I would just also say that the overall project, we've been making a lot of steps with this over the last few weeks. I felt so confident in the ARM aspects were non-issues to where had I had the code ready from the upgrade side, I would have actually rolled it on a Black Friday. Not because to be too bold, but just rather it's EC2 and I trust it and it works and I know how to roll back easily too. But once we get our photoserve tier on it, which will be solved about 95% of our code challenges, then we're going to start looking at other tiers of machines. Maybe the primary web servers, maybe some things that handle uploads or other things like that. So we are constantly looking always at, as new instance types come out, to find the best fit for things. I also want to mention, we profiled these processors and ran different types of encryption tests and other things like that. And we found there are many cases these were faster than Intel's, and a few cases when they were a little bit slower. And so I would just want to encourage everybody, when you take a chance with the ARM processors, make sure you profile your workload on it. Because, yeah, we can come up with these synthetic tests, but they might test something that your code never would need. Or vice versa, they might exercise a part of the code that the ARM stuff doesn't quite perform as well as Intel will for you. So just make sure you find the right workload and the right processor match for your needs. Yeah, so we're going to continue testing each workload and move a lot of things to A1 as time permits. And we're going to, like I said, also explore the spot market, because anything to drive down our spend on EC2 is a good thing, because it frees up resources to go to building other neat things for our customers, be able to continue delivering value, and just delivering our customers' photos to them a fantastic experience. So thank you, and I'll hand it back over to Ollie.
Thanks for the... I'm glad it was so smooth. Next, I'm going to talk a bit about the software ecosystem, and just echoing what Shane said about how, if you're running an open source stack, as many people are who build applications in the cloud, the ARM ecosystem is really well developed at this point, and it likely already supports your application. We've got 4 great operating systems supporting on the A1 instance: Amazon Linux 2, Ubuntu 16.04, Ubuntu 18.04, Red Hat Enterprise Linux. I just heard today that Fedora is running on it. And the previous 4 are all available on the Quick Start page. You can launch them today. And these operating systems are offering the same level of support for their ARM AMIs as they do for their existing x86 AMIs. And in almost every case, if you're installing packages with apt or yum on one of these instances, it's going to work exactly the same way as it does on an x86 today. It means if you want to install Nginx or PHP or Ruby or Python or MariaDB or any of these things, you can just type apt-get install or yum install, whichever one is appropriate, and get that software installed without any changes. After this week, we're going to be working with other operating system vendors to get support for the A1 instance as well. We also have a couple of ISVs, both Cadence and Synopsys, have been running some of their tooling on the A1 instance and showing that it works there as well. And I'm sure there'll be some others in the near future. Next, I'd like to talk about containers. The majority of Docker official images contain support for ARM64 systems. There's an ECS-optimized AMI that's available today for Amazon Linux 2 that has Docker, ECS, the ECS agent, ECS init, all pre-installed. We added support to the Elastic Container Registry to support ARM containers. And coming soon, EKS, the Elastic Kubernetes Service, will support ARM as well. We've also added support in A1 for some other tools in AWS. One is Marketplace. This is our managed and curated software catalog. Support there is now there for A1, and you'll see AMIs turn up there where you have the same pay-as-you-go hourly pricing as you do for the x86 instances. In addition, Systems Manager and CloudWatch both support the A1 instance. And for developers, Cloud9 lets you write, debug, build, and run code in a web browser on an A1 instance today. We also have support for Code Pipeline and Code Commit. And in the near future, we announced AWS Corretto, our OpenJDK, supported version of OpenJDK, and you'll see support for that available on A1 shortly. So we've got some demos to show you. The first, I'm just going to start by showing how familiar it is to use the A1 instance to anyone who uses our existing instances, and just echoing some of the things Shane just said. And then we've got a demo from Canonical, the makers of Ubuntu, running an Android game on top of an A1 instance and streaming the experience to a mobile device. And lastly, a demo from Red Hat of running a tweet sentiment service in containers on an A1 instance. So with that, I'll just start with how you run one of these. And in a sense, it's boring. It's the exact same way you do it today. You can go to the EC2 dashboard, click the Launch Instance button. On Monday night, we added radio buttons under the AMIs, so you can select the instance. Select the architecture. And now you can select 64-bit ARM. So if you select that and click Next, you're now offered the ARM instances that we support. Any of the 5 are available. I've selected an extra large in this case. And after this point, every other screen on the launch wizard looks exactly the same as it does on any other instance. And it turns up in your dashboard that it's running. And then, if you want to SSH to it, that works too. I've run uname here and looked at the top of the boot just to point out that it is really an ARM system that's running. Otherwise, you wouldn't notice. And I decided to install Nginx. So I installed Nginx. I didn't show it, but I edited the index.html a little bit just to call out A1. And sure enough, again, it works exactly like you'd expect. You can also install Docker in the same way. So here's me installing Docker. And then running a very simple Docker container, the Hello World one. But it does nicely list both the architecture and show Docker's features of picking the container that matches the operating system and architecture transparently. So next I'm going to show a demo from Canonical, running an Android game on an A1 instance. So we're going to start with a high-level overview of what Canonical is doing here. They've got Android running in a number of LXD containers on an A1 instance, and then they're going to stream the graphical output of the game to a mobile device. And they're using Juju and LXD to do this. So first they bootstrap it. And at that point, they've deployed the entire software stack onto the instances. They've got a APK for an Android device that they're going to upload now. And now we can play the game. So the game is running on an A1 instance, and the content's being rendered, and the touch input on a mobile device. Takes a few tries to actually get the ball in the hoop, but there we go. No. One more time. There we go. So if we go ahead and look inside these containers, they have 10 LXD containers that are running. And they really are running an Android system. They can look inside of them. You can see the Android processes running. And it looks like any other Android with all the properties there. But it's running on the ARM architecture. Okay. Lastly, we have a demo from Red Hat using Kubernetes on ARM to process tweets about the weather and put on a map of the US smiley or sad emojis based on the sentiment about the weather at the time. So here's that map of people being happy or not happy. So the way this is going to work is from the Twitter streaming API, we're going to get the stream, send it to AWS Comprehend to get some sentiment analysis, put the results in a SQL database, and then have a set of web servers that can query that database and provide the web page to a user. So in this, there's 3 nodes that are going to be used. One's a Kubernetes master and 2 Kubernetes nodes. And just back to that same console page, showing 3 instances that have been running. They're running RHEL 7.6 in this case. They've been up for a little while. The vendor's Amazon EC2. And here we can deploy first MySQL. Then TwitterBot. And lastly, the web server. And you can see all those running And that's how the demo at the start of the presentation was created. So in all these cases, these are kind of very familiar things that you do on any of our instances. None of that's changed. The software ecosystem is really robust. If you're using an open source package, there likely is support already that you don't have to change anything. So finally, I'm going to hand it back over to Sudhir to wrap up.
All right, thank you, Ali. Those were some fun demos. So we are close to wrapping up here. So in summary, just wanted to recap some of the key points. That the A1 instances are the first instances powered by the AWS Graviton processors. These are processors that are custom designed by Amazon, and they feature 64-bit ARM Neoverse cores, as well as custom silicon that's designed by AWS. And the A1 instances deliver cost benefits for scale-out workloads and for ARM-based applications. So to learn more, you can visit our website. We have all the documentation out there. We have some FAQs. We have our technical documents updated as well to help you get started on the A1 instances with callouts on the specific armies that you can use. And that's pretty much it. So thank you so much for attending. And please don't forget to complete the survey in the mobile app. And our session ID there is CMP391. And thank you. Thanks for attending.